Hi, I'm Shaul. In this video I will further discuss or develop some topics that were the subjects of previous videos. First, the question whether the camera sensor has an impact on depth rendering of images. As we discussed in length over many videos in this channel, the optics, the lenses have a significant effect on the rendering of the camera, of the final result obtained. The main effect is due to the types of glass used in the lens, which have a major effect on contrast, on chromatic aberration and other flaws of the glass. Now does the sensor itself have an effect on the rendering of the image? My first instinct is to say no, because I treat the sensor as a medium that collects the light passed through the lens and records the analog signal in a digital format or file. According to this hypothesis, we should look at the sensor as a neutral recording and converting medium that does not have a significant effect on what is transmitted by the lens. We should really look at the whole area of the sensor rather than individual pixels. However, it is also true that the rendition of depth is a result of a micro effect. In other words, of the blurring around the edges of surfaces as dictated by the amount of light dispersion allowed to develop through the lens before the light hits those pixels. So if we mount the same lens at the same settings on two different cameras, one of them with a larger pixel and the other one with a smaller pixel, the resolution or the size of the pixel might have a slight effect on the appearance of edges of surfaces, depending how large the edges appear in the whole frame, and what is the level of nuance in brightness between two adjacent surfaces. In that context, there is another issue here. Lower resolution sensors are usually fitted with an anti-aliasing filter which is responsible for a very slight blurring of the image to avoid moire and other artifacts, while higher resolution sensors typically lack such an anti-aliasing filter. So in principle, there is even more blurring going on in large pixel pitch cameras. So to conclude this issue, I am not sure. It's something that is worth further exploration, and I will try to do it in the near future. Just keep in mind that I do not own a really high resolution camera. I only have 12 megapixels and 24 megapixels full frame cameras, which are both fitted with anti-aliasing filters. But I hope to draw a conclusion, at least in principles, from this test. In practice, lower resolving power lenses will portray the scene in a more poppy way than a higher resolving power lens that is full of low dispersion glass. I think that mounting such a low resolving power lens on one of those very high resolution cameras is a bit of a waste, because even a lower resolution camera can make the most of that lens. That is going to be typically more affordable and perhaps more convenient to use. The photos in the background were actually taken yesterday with rather what can be considered primitive gear. I used a Nikon D780 camera with only 12 megapixels, albeit those pixels are fat and really juicy, with a pixel pitch of almost 8.5 pixels, and some 90s era zooms. That older, perhaps less clinical setup created really nice and poppy images, and aberrations are well suppressed in that lower resolution. Anyway, I'm planning to explore this issue of the effect of sensor resolution on image rendering in the coming week. So please stay tuned, and we'll have a longer discussion after I finish performing this little experiment. The second topic of this video is a clarification about my idea of going back to screw drive systems. By that I do not mean adapting older, existing screwdriver lenses to the new mirrorless cameras. That has been done, at least in a few cases. Sony developed a few adapters that allow mounting old Sony and Minolta screwdriver lenses onto E-system cameras, and there is also a newer third-party solution for adapting screwdriver Nikon lenses onto E-mount cameras. What I meant was using a screwdriver system to mount a novel series of low resolving power lenses that may render poppy images onto mirrorless cameras. Those lenses should be themselves autofocused by a screwdriver system where the autofocus motor is located in the body rather than in the lens. That will allow the lenses to be cheaper and also more reliable in harsh physical conditions, because they will lack all those electronics that are used for autofocus. In the last video I experimented a little bit with the Nikon D780, which is a hybrid DSLR and mirrorless camera, which is the only camera currently on the market that can use screw mount lenses for practical video and continuous autofocus applications. As we have seen, even that old screwdriver system is good enough to keep up with real life scenarios. It is rather efficient. It is fast enough and adequately smooth to allow for good video autofocus. Of course, the motor used in the D780 is an old system. It's basically a servo-type motor that takes large jumps to achieve autofocus. Now, a modern screwdriver autofocus motor would be more suited for video application. It would be probably a stepping motor that can make smaller steps and support a combination of phase different autofocus and contrast autofocus that is used in mirrorless cameras. Stepping motors are also, at least potentially, quieter than servo motors. So that is another big advantage for shooting video. Although the motor inside the D780 is certainly quiet enough for my purposes. You cannot really hear the lens autofocusing in the footage. The last topic of this video is the D780 itself. If you missed the previous video, this is the D780. It's a DSLR that actually has a mirrorless mode. By pressing this little button, you can achieve mirrorless functionality through the main LCD of the camera. It can achieve fast autofocus with the autofocusing area covering the whole frame, unlike DSLRs where the focusing area is concentrated around the center of the frame only. Now this camera has two disadvantages compared to modern mirrorless cameras. One is the lack of an electronic viewfinder. The camera's viewfinder is optical only, of course, because it's a DSLR mainly. And the second disadvantage is a lack of any kind of stabilization. So to mitigate those two disadvantages, you need two rather cumbersome accessories to make it more functional for video shooting. The first one is a loop like this that allows you to use the screen of the camera as a viewfinder. You mount that loop onto the screen of the camera, so it looks like this. Then you can see the whole viewfinder through this loop. This way. So by that you achieve a huge, bright view of the scene through this newly formed viewfinder. The second accessory that is used to stabilize the whole camera while walking with it is a pistol grip, like this one. You can mount it to the screw at the bottom of the loop, so you can operate the camera this way, which makes it really well stabilized. It's comparable to sensor stabilization inside the modern mirrorless cameras, and it's very useful. I'll show you an example of the stabilization you get while walking. Of course, this whole thing is an abomination. It's quite large, although it doesn't add much weight to the camera. And it works quite nicely. Now, I do recommend using a pistol grip like this one for shooting video on any camera, because it really adds stabilization. When you walk, this way of holding the camera gives you a 3-point grip. Looks like this, and it's a rather stable way of holding a camera for shooting video. That was all for today. Thank you for watching.